Welcome to 6.5, Divide Monomials. Here we look at two objectives. We're simplifying expressions using the quotient property and quotient to a power property. If you recall, this is very similar, sounds very similar to the power property, the product property. So we're going to use the same idea, but it has its own rule here, instead for quotient. Okay. To begin with, let's have a quick refresher on the equivalent fractions property. So you've learned this in Math 80. We also looked at this in Chapter 2 when we began this course. If you have A over B, right, you could multiply the same factor up and down, and it will not affect the value of A over B. Right? So if you had, say 5 over 7, okay? So if I had 5 over 7, and if I multiplied the numerator by, say, 3 and the denominator also by 3, it does not affect the value of the fraction, even though the fraction itself changes into 15 over 21. It is equivalent to the 5 over 7. When I say equivalent, it means they carry the same value. So if you pulled out a calculator and did 5 over 7, you're going to get an answer, right? That answer will be the same as 15 over 21. Okay, that is to show that the value does not change, even though you have changed the fraction. Likewise, what they're saying is, if you started with 15 over 21, right? Yeah, this can be reduced because you could rewrite this as factors, right? 5 times 3, 7 times 3, and you could cross cancel the 3's, leading you to 5 over 7. This is the reverse of the previous step. So what they're saying is, if you had 15 over 21, you could reduce that to its lowest term, such it turns out to be 5 over 7. Both of them will carry the same value, right? So you can either bump it up or reduce it down to create infinite possibilities of equivalent fractions. That's what the property says. So quotient property for exponents here, it says, well, if you have a power m over a power n, right? If you have the divisions, you have like bases, but they are being multiplied in the product property, but they're being divided in the quotient property. And so you want to watch out what they're doing. Are they multiplying or are they dividing? So here it's division, and so we subtract the powers. If they multiply, we add the powers. So subtract the powers. And how do we subtract them? Top power minus bottom power. Okay. This is good if your top power was bigger than the bottom power. If the top power is smaller than the bottom power, then you want to collect all the powers in the bottom. So the rule here changes. It says, well, if I'm going to collect everything in the bottom, I can't have anything blank there in the top. It has to be a 1, right? You can't just have a 0 or something without any number. It has to be a 1. So it is 1 over a power, bottom power minus the top power. Okay. So just remember this way. If your top power is higher, collect all your powers on the top. So top minus bottom. If your bottom power is bigger, collect all your powers in the bottom. So bottom power minus the top power. Because you're collecting it in the bottom, you need to have something on the top, and it has to be always a 1, right? You can't have any other number. Okay? If you're thinking 0, 0 over anything becomes 0, so that's useless, right? And if you're thinking of any other number, how do you justify it? How do you justify a 5 or a 7 or whatever? So it's always a reciprocal, so it's always a 1. Right? So you can't really forget or mess up this rule. Let's look at this problem. Let's do A. X power 9 over x power 7. Okay? The top power is bigger. That means you're going to collect them all on the top. So collecting on the top means top power minus the bottom power. Now, it's as if you had a 1 underneath it, but you're not going to write that, right? So x power 9 minus 7 is 2. That is by applying the rule. By concept, okay. By concept, I simply will have to expand this, right? It's going to be painful. I'm going to write this 9 times. 1, 2, 3, 4, over x power 7. That has to be done 7 times. 2, 7. Because they're all being multiplied and they are like terms, they can be cancelled off up and down. Okay, see how many you have left. You just have 2 x's left. So the power is 1 and 1, 2. That is the answer we just got by using the rule, right? Clearly, the rule is way better to apply, provided you understand the concept behind it. Okay, 3 power 10 over 3 squared. Again, the top power is bigger. So we're going to combine them all on the top using the rule, of course. So the top power minus the bottom power. You just have to have one base, right? Because you're collecting your powers. So you just have one base, which is 3 power 8. Again, now we don't expect you to expand this, so you can just leave it as it is and box the answer. Let's try this one. A power 5 over A power 9. So see where your power is bigger. The power is bigger in the bottom. That means you're going to collect them all in the bottom. Okay. You're going to collect it in the bottom, A power 9, which is the bottom power minus the top power. Because you're collecting in the bottom, you can't leave the top blank. So the top becomes a 1. It's always a reciprocal. So it becomes that, which reduces to 1 over A power 9 minus 5 is 4. Again, if you were to check this by concept, if you expanded it, you'll have everything cancelled off on the top, leaving you with 4 A's in the bottom, and that will become A power 4. B, my line is crooked. Okay, x power 11 over x power 7. You always want to see which one is bigger. So this is bigger. So it's going to be combined on the top. So x power 11 minus top power minus the bottom power, which is x power 4. Then we have the zero exponent property. This is very important, but a very simple property. Anything power 0 is 1, as simple as that. When I say anything, there is a little catch. It should not be a 0, okay, in the base. So a non-zero number, power 0 is 1. Okay. So anything power 0 is 1, but it cannot be the base cannot be a 0. Okay. Meaning 0 power 0 is undefined, okay? So I'll just say anything power 0 is 1. Put the 0 properly. This anything cannot be 0. Okay? 0 power 0 is undefined. Can't really define it. So just remember that, okay? We won't try to trick you, but it's good for you to remember that it cannot be a 0 in the base. All right, so let's come over here. Part A, 9 power 0. So we just saw anything power 0 is 1, so the answer is directly a 1. In fact, you could try this on your calculator. You're going to get the answer as 1. N power 0. Okay, if it's n, you can't really use a calculator because you really don't have a number to calculate. But remember, it doesn't matter. Anything power 0. N is supposedly a number, but in n power 0, anything power 0 is 1. What your answer is 1. Okay, let's look at this one. 5b power 0. Okay. So the 0 is your power. What is your base? Your base is grouped. So your base is collectively the 5 and the b together, right? So that is your base. So any base power 0 is 1. So this is the easiest way to argue and get the answer. But there's also another way to look at this. If you were not paying attention to that, you should, but if you were not paying attention, then you could also alternately, you have, you could use the, what was it? Power to a product rule. And you could individually distribute the 0 to each of the factor in the base. 5 power 0 is 1, b power 0 is 1, 1 times 1 is 1. Okay. You'll still get the answer. It's just that you have to go through more steps. So if you were to reason out that the base itself was 5b, then that any base power 0 will be a 1. It will be an easier argument. So let's try this one. Negative 4a squared b the whole power 0. What is your base? The whole thing is your base. So no worries. Any base power 0 is 1. And that will be your argument. Next, we have quotient to a power property. Okay. So we saw product to a power property in the previous lesson. Here it's quotient to a power property, very similar to the other one. In the product, we saw AB power M, A times B. If you have a product, okay, if you have multiple factors in your base, then each factor gets the power M, right? That was a product to a power property. But here you have the quotient, which means your A and the B are being divided. So A over B power M is that each one gets the power M. So A gets the power M on the top, B is in the bottom, so B gets the power power M in the bottom. Raise the numerator and the denominator to that common power. So let's look at this one. 3 over 7 power 2. Okay. Now, if you were trying to see it as base and the power, then you know your base is 3 over 7 because it's grouped, and the power is 2. So you might say, well, I'm going to do 3 over 7 times 3 over 7. Multiply them across. 3 times 3 is 9. 7 times 7, 49. And you could get the answer, which is totally fine. But we didn't use the property, right? If we were to use the property, you would simply say, well, it's going to be 3 squared over 7 squared because each of them will get the power. And that will make it 9 over 49, right? It's quicker and it's helpful when you have larger powers. Also helpful when you have letters, because you really don't have to expand it and combine it again. You simply can leave them as the letter to the power. Okay, b over 3, the whole power 4. Again, I don't want to multiply this 4 times over. I'm going to use the property. So that's going to be b power 4 over 3 power 4. b power 4 cannot be expanded, but 3 power 4 is 81. Just like that, you get your answer and you can box it. And the third part is k over j, the whole power 3. Look at that. That's going to be simply k power 3 over j power 3. Can't do much to it, so that's just your answer, right? This is where I like it because you really didn't have to multiply k over j times k over j times k over j to get this answer. You directly get the answer. Okay. And here is a summary of all the properties, including the product, the quotient, and the 0. Okay. So we're going to use the combination of these properties for the following problems. Y power 4 power 2 over y power 6. Now, there is no one set way of doing this because you could see it as a different combination of properties and I could see it differently. So if we arrive at the correct answer through valid steps, then you're fine. Okay. So here I see the powers stacked up. So I make it as 4 times 2 over y power 6. And that's going to be y power 4 times 2 is 8 over y power 6. So that's my first step. The next step is I see that the power on the top is bigger. So I'm going to combine the powers on the top, 8 minus 6, which is y power 2. I box the answer. When I use the properties, it comes out very quickly. Okay. So it again depends on what kind of properties you're using or how you're viewing them in order to see how quickly your solution is arrived. Okay, b power 12 over b squared the whole power 6. This is b power 12. This will be 2 times 6 because the powers are stacked. B power 12 over B power 12, okay. So here again, you see that they're exact terms up and down. So you could see it as a way of cross-canceling it. Remember, I'm trying to apply the properties. So I would, which one is bigger? I mean, I can't decide because both are equal, right? So if they're equal, it's just easier to combine them on the top. So 12 minus 12, right? Which is B power 0. 12 minus 12 is 0. B power 0, what is anything power 0? That is a 1. So you got your answer. You could have arrived at this answer right here by doing B power 12 over B power 12, canceling them off. But that's a little tricky if you are not strong about your understanding of power and base and when to cross cancel. That's why I do not recommend that at this point. When you are more mathematically mature, you could try those things. Okay. Technically, when you're done with all your algebra, then when you see this again in higher levels of math, that is where you will try to apply these things because you feel more confident about having mastered these topics. All right, let's come to this. Y power 9 over y power 4 the whole squared. Okay. Now again, there are many approaches to this. Excuse me. You could see the power 2, the overarching power 2, as being distributed to the numerator and to the denominator powers. That's one way to see it. The other way is to see it as PEMDAS, where you will begin working on what's inside the parentheses first, and then go to the power that's outside. That's another way to do this. Basically, when you're doing PEMDAS, you're actually doing the quotient rule, which is subtracting the powers. So again, it's what you choose to do. So here, I just choose to combine what's inside first. So I will do y power 9, that's a bigger power, minus 4. All this is inside the parentheses. I'm not touching the 2 yet. So y power 9 minus 4, which is y power 5, the whole squared. Now I'm ready to multiply the powers because they're stacked. Gives me y power 10. That's the answer. As long as you get the same answer by using valid steps, you're totally fine. Let's wind up with this one. X cubed power 4, x squared power 5, all over x power 6 power 5. Okay, instantly I see that each term has stacked powers. So I kind of decide what method I'm going to use. So I'm going to work on the power property. So I'm going to have 3 times 4 because the powers are stacked. I will multiply them. 2 times 5. 6 times 5. So that's going to be x power 12, x power 10 over x power 30. Okay. Now I look at the numerator. Denominator is simple. It's got just one term. The numerator has 2 like bases with different powers that are being multiplied. So if they're being multiplied, I have to use the product rule, which means I have to add the powers. 12 plus 10. It's a good idea to hold on to the properties by your side so you can quickly cross-check which one it matches. Oops, let me clear that. X power 30. So that's going to be x power 12 plus 10, 22, over x power 30. Now we've got single terms on the top and the bottom. So it's time to compare the powers, and you see that the power is bigger in the bottom. So I want to combine the powers in the bottom. So it's going to be bottom power minus the top power. Because I'm combining in the bottom, the numerator takes a 1. Therefore, my answer is 1 over x power 30 minus 22 is 8. 1 over x power 8 is the answer. Okay. I hope you enjoyed this section. I will see you in the next one.